Okay, so the first thing to go over here is that t of 1 and a of 1, these are the same thing. So the small number right here just tells you which term it is. So t of 1 and a of 1 just means the first term. So this is our sequence down here. We've got 2, 4, 6, 8. So my first term is 2. And then my second term, see how there's a 2 right here, is going to be 4. My third term is 6, and my fourth term is 8. Okay, so t of 1 and a of 1 is just a way to represent the first term. Okay, so you might see it both ways. You might see using t, you might also see it using a. Doesn't really matter, it means the same thing. So now this is what we call a recursive formula. All right, so if we have a sequence that we are either adding or subtracting, so an arithmetic sequence, this is what you're going to use, okay? So we've got t of n equals t of n minus 1 plus d. Now let's kind of break that up and see what that means. So t of n, we know that n tells us which term we're looking at. So we're going to plug in any number we want for n to be able to find that term. Okay, so if I plug in 1 for n, then that's going to tell me what my first term is. And then t of n minus 1, that just means the previous term. Because if I'm just taking 1 away from n, that's going to give me the number that came right before it. So let's say that I was looking at the fifth term. So I have t of 5. Okay, so if we're looking at t of 5, so the fifth term, then right here I'm going to have t of 5 minus 1, which 5 minus 1 just gives me 4, so then I've got t of 4. So the fourth term, which that makes sense, right? Because the fourth term comes right before the fifth term. So this is just the previous term of what we were looking at. And then d, this is just the common difference, okay? Common difference. And that's just whatever number we're either adding or subtracting by. All right, so for the example I just gave you, 2, 4, 6, 8, we're adding 2 to each number. So I'm just going to put plus 2. Okay, so here we've got our first term, second term, third, fourth, and we want to find out what is the fifth. Obviously, we see what the pattern is, and we would be able to just add 2 to 8 and figure out that it's 10, but let's use our formula. So we already plugged all this in, right? We want to find out what is the fifth term, so we plugged in 5 for n. And so in order to find it, we need to know what the previous term is, which the fourth term is equal to 8, so I'm going to substitute 8 right here. Okay, and then now my equation is just 8 plus 2, which is exactly what we need to do in order to get our fifth term here. So that's how you would use a recursive formula to find the missing term of an arithmetic sequence. Okay, so now we're going to still be looking at the recursive formula, but instead of an arithmetic sequence where we're adding or subtracting, we're going to look at the geometric sequence where we're multiplying. So if we look at this pattern, I can tell that I'm just doubling it every time. So 5 times 2 gives me 10, 10 times 2 gives me 20, 20 times 2 gives me 40, and then we could predict what would come next, but we're going to use the formula just so we can practice with it a little bit. So the formula I have written right up here, and it's very similar to the one that we just did, right? We have the t of n, which is the term that we're trying to find. And then we've also got t of n minus 1, which is the previous term. The only difference now, instead of adding d, instead of plus d, we're multiplying by r. So r represents the number that we're multiplying by. So for this sequence, we're multiplying by 2. So that means my r is equal to 2. So my formula will look something like t of n equals 2 times t of n minus 1. Okay? So now let's see. I've got 1, 2, 3, 4. I want to find the 5th term. So that means I'm going to plug in 5 everywhere that I see an n. So I'm just going to erase this n and this n. We're going to put a 5 here. Okay, so I'm going to find the 5th term now using my equation. So we know that t of 5 minus 1 is just t of 4, right? And t of 4 is equal to 1, 2, 3, 4 is equal to 40. That's my 4th term. So really all I'm doing is 2 times 40. And that gives me my 5th term, which is now going to be equal to 80. So we just finished going over recursive formulas. Now this one that we have here is an explicit formula. So the difference between recursive and explicit is that you don't need the previous term. So this one is actually more helpful because you can plug in any number for n and you don't need to know the previous term, and you can still figure out what the term is that you're looking for. So let's go over what all this means because it looks kind of confusing, but we're just going to break it down. So t of n is still just the term that we're looking at. We can plug in any number for n and it'll give us that term. So for this one, we want to find the 1, 2, 3, 4, 5th term again. So we're going to plug in 5 for n. And then here we've got t of 1, which that 1 tells us that it's the 1st term. So we're going to plug in right here whatever our 1st term is. So I look down here and I see that it's 3. So t of 1 is just the 1st term. And then d is still the same thing that it was in the recursive formula. It's the common difference. So it's the number that we're adding by. So when I look at here, to go from 3 to 5, I have to add 2. And then to go to 5 to 7, I also have to add 2. And then 7 plus 2 gives me 9. So I know that my pattern here is just plus 2. And then n minus 1 right here, you just leave that the same. That's just a part of your formula. So now let's write out what this formula looks like. So we've got t of n equals the 1st term, which is 3, plus the common difference, which is plus 2, times n minus 1. Now, we want to find out what is the 5th term. So I'm just going to go back and erase all the n's so that I can plug in 5 for n, because I want to find the 5th term. So plug in 5 here, plug in 5 here. Now you just solve it. So we know PEMDAS, you have to do order of operations. The very first thing that you do is parentheses. So the first thing I'm going to do is 5 minus 1. So I'm going to just rewrite this now. 3 plus 2, and then 5 minus 1 equals 4. Alright, so after parentheses, there's exponents. I don't see any exponents. And then after that, we multiply. So now I'm going to do 2 times 4, and that gives me 8. And then the final step is just to add these. So now I've got 3 plus 8, and that gives me 11. So 8 plus 3 gives me 11. So now I know that my next term is 11. So t of 5 is equal to 11. Alright, so now we're going to go over the explicit formula for geometric sequences. So once again, we still have the term that we're looking for right here, t of n. And then t of 1 is still just the 1st term. And then r is the number that we're multiplying by. And then n minus 1, that's going to be in the exponent. So we have r raised to the n minus 1 power. So now let's plug this in, let's figure out what the equation is for this sequence here. So I'm going to just write t of n equals t of 1, which is 3, and then times r. So now I got to figure out what am I multiplying by in this sequence. So what times 3 will give me 6? Well, 2 times 3 is 6, and then 2 times 6 is 12, so I must be multiplying by 2. So my r is going to be equal to 2 because that's what I'm multiplying by. So I'm just going to plug in 2 right here, and then my exponent is just n minus 1. Okay, now I want to find out what the fourth term is. So I'm just going to go back and plug in 4 for n. Okay, so now I've got t of 4 equals 3 times 2 to the 4 minus 1 power. So let's start what's inside the parentheses. So let's do the exponent. So 4 minus 1, that just gives me 3. I'm going to erase that and put 3. So now it looks a little easier. So I've got 2 to the third power, which is the same thing as just 2 times 2 times 2, which is going to give us 8. Okay, so inside of the parentheses I've got 8. 2 to the third power is equal to 8. So now I've just got 3 times 8. And 3 times 8 is equal to 24. So that means that my fourth term is equal to 24.